So in this video, we are going to continue our discussions on chapter number 6, lines and angles. So in this video, we're going to talk about parallel and intersecting lines. Okay, these are the only two different types of lines possible when you want to draw two lines on a piece of paper. Okay, let's read this task which is given to us. Draw two lines on a paper. So the task is asking us to draw any two lines on a piece of paper. Let's say, okay, let's say this is my line number 1 and this is my line number 2. Okay, so we can clearly see that after certain point, okay, if I extend this like this and if I extend this line like this, okay, at after certain extension they are going to intersect at some or the other point. Note one very important thing which I missed actually in this video is that the lines always have an arrow at both the ends. And what do the arrow indicate? The arrows indicate that the line extends infinitely. Okay, both these lines extend infinitely on both the directions. Okay, so these two lines they will meet here after the extension. So these two lines are example of intersecting lines. Let's continue with some more examples. Let's say I draw two lines like this, okay, and like this. So once again, the arrows are very important. The arrows indicate the infinite extension on both the sides of the line. Okay, now once again, if you see these two lines, they are not intersecting at the moment. But if you extend them a bit further, so I'll extend this like this, and I'll extend this like this. Yes, this is where they intersect. So once again, these two lines that we are trying to draw on the paper and even these two lines that we try to draw on the paper are both example of intersecting lines. Are intersecting lines the only two are intersecting lines the only possible ways to draw two lines on a piece of paper? No. We can also have something called as parallel lines, which are parallel lines by definition means the lines which never ever intersect with each other. And the best example of parallel lines are these lines that you see which are there on a piece of paper. These these gray color lines, these are in fact parallel lines. Do they intersect with each other? Even if we extend them beyond this screen, these two lines will never ever intersect each other. So just for the sake of understanding, I'm going to draw a line on this line itself. This is my line number 1 and this is my line number 2. These are my arrows which are very important. They indicate that the line extends infinitely. Okay, now let's try to zoom in. Yes, now look at these two lines. If I extend these lines on either left hand side or right hand side, either left hand side and right hand side, they are parallel to each other. Okay, they are never ever going to meet or intersect each other even after extension. So hence these lines are called as non-intersecting lines or parallel lines. Now the unique property of parallel lines is the distance between two parallel lines is always constant, and that is the main reason that they will never ever intersect each other. If you measure the distance between these two lines at this point, and if you measure it at these 2 points, and if you measure at these 2 points, any two random points, okay, even if you measure at this point and this point, or this point and this point, or even if you extend and measure at these 2 points, the distance, the perpendicular distance between these two lines is always the same. It is the constant. This is not the case with the intersecting lines. If you look at the intersecting lines, the distance between these two lines here is different. These two lines here is different. These 2 points here is different. Sorry, was I saying lines? What I mean was points. At each of these points, the distance between these two lines is never constant. It is different, and hence these lines intersect each other in the extension. Observe this same phenomena, very important phenomena here also. The distance between these 2 points is different, these 2 points is different, these 2 points is different, and that is the reason that they intersect each other. And this is not the case with the parallel lines. So let me just remove this. Yep, let's remove this highlighted thing. So thus, when a task was given to us, that the task was to draw two lines on a paper, we figured out there are two types of lines that can be drawn on a paper. One is this intersecting lines. Okay, even if they don't intersect at this point, if you extend them, they will intersect somewhere. So one is intersecting lines, and the other type of line is parallel lines. Parallel lines is exactly opposite of intersecting lines. which basically means that they will never intersect each other. You can call them non-intersecting lines. So this was an important discussion between parallel and intersecting lines. Now let's go for ahead, and there are important two axioms that we have to understand in terms of angles and lines. First we'll see what is axiom number 1. Okay, let's read out the axiom. The axiom reads, if a ray stands on a line, we know what is a ray, we saw in the previous video, we know what is a line. If a ray stands on a line, then the sum of two adjacent angles is 180 degree. Okay, let's try to visualize this statement step by step. So I'm going to use a highlighter. Okay, so if a ray stands on a line, okay, so let's first try to visualize this. This is, okay, this is, let's draw a line first. So this is my line. Okay, and it says a ray stands on the line. So we all know what is a ray. A ray is the one which has one endpoint, okay, and one infinite thing. So this is the endpoint, okay, here of the ray. And the ray is standing on the line. So this is the ray which stands on the line. Then the sum of two adjacent angles. So now this is another important statement. Two adjacent angles. So we know what are adjacent angles. Adjacent angles are angles which have common endpoint and common arm. Okay, so this is important. Let me try to write it. Okay, we have seen this in the previous video. Adjacent angles are the angles which have common endpoint. Any two angles that have common endpoint plus common arm, they are called as adjacent angles. So now the sum of two adjacent angles. So which are the two adjacent angles? Okay, this is adjacent angle number 1, this is adjacent angle number 2. Let me use okay. So the sum of these two adjacent angles is 180 degree. Okay, so if we try to give them names, let's try to give them names. So let's call this as A here, let's call this as B, and let's call this as C. Okay, so the axiom says that angle A, okay, and let this be O. Angle AOC plus angle AOB is equal to 180 degree. Quite simple and straightforward axiom. Now let's try to read this axiom in its entirety. So if a ray, stands on a line, so we have this ray OA, which stands on this line BC, then the sum of two adjacent angles, this is one angle, this is one angle, both these angles are adjacent, is 180 degree. So angle AOC plus angle AOB is equal to 180 degree. So this is the axiom of a line and a ray which form adjacent angles. Now quite similar to this axiom, but kind of a converse of this is the next axiom that we have. Let's try to reveal it. Yes, axiom 6.2. Let's try to read it step by step. If the sum of two adjacent angles is 180 degree, as I said, this axiom is reverse of the previous. So it has started from this, the second half of the statement. If the sum of the two adjacent angles is 180 degree, okay, then the non-common arms of the angles form a line. Okay, so once again let's try to visualize this. First of all, it says sum of two adjacent angles. So let's try to draw adjacent angles. So let's say this is my adjacent angle 1 and the important point is the sum. So okay, hold a minute. This is my adjacent angle 1. So I'll just mark here cross. Let's call this O, let's call this P, and let's call this Q. Okay, so this, now I have to draw another adjacent angle with OP as the common arm, and I have to ensure that the sum of the two adjacent angles is 180 degree. So again I have to extend this, and the way I do this is like this. Oh, sorry. Oh, okay, cool. So this side. Okay, so this becomes my another adjacent angle here. Let's call this R. Okay, so POR and POQ, these two are my adjacent angles, and the sum of the two adjacent angles is 180 degree. Okay, so again let's note it down. Angle POQ plus angle POR is equal to 180 degree. If this is the case, if the sum of two adjacent angle is 180 degree, then the non-common arms, so this is the common arm and this is the common midpoint for the two adjacent angles, but this is the non-common arm, which are the non-common arms. So yes, OQ and OR are non-common arms, okay, of the adjacent angles. So then this axiom says the non-common arms of the angles, they form a line. So this ROQ, or rather RQ, is going to be a line. It's going to be a straight line because the sum of these two adjacent angle is 180 degree. So this is our axiom 6.2. So both these axioms 6.1 and 6.2 are kind of complementary to each other. They talk the same things in a reverse manner. So the first one says that if there's a ray on a line, then the sum of adjacent angle is 180 degree. The second one says that if the sum of the adjacent angle is 180 degree, then this has to be a straight line. So these are the two axioms that we have. As we know by definition, axioms are something which we do not prove. They already exist and we take them as a fact. We take them for granted. And using these axioms further, we try to prove our theorems. So one important and the first most important theorem that we are going to see in this chapter is as follows. Okay, let me try to read it out. If two lines intersect each other, then the vertically opposite angles are equal. Okay, quite simple to visualize. Let's try to visualize what the theorem says. The theorem says if two lines intersect each other, so let's draw two lines. Let's say this is my line number 1 and let's say this is my line number 2. And again, for lines, the arrows are very important because the arrows indicates infinite extension. Okay, if two lines intersect each other, yes, we have two lines intersect each other, then the vertically opposite angles are equal. Now again, we have seen what the definition of vertically opposite angles. These are the vertically opposite angles. This and this is one vertically opposite angle, and this is another vertically opposite angle. Now the theorem says that these vertically opposite angles are equal to each other. That means if you measure the value of this angle and measure the value of this angle, it's going to be exactly the same. Now this is a theorem. Note, this is a theorem, it's not an axiom. So we need to prove this theorem. So it's very easy to prove this theorem. What I'm going to do is, yes, let's try to erase this. Okay, I'm going to erase this. Okay, and I'm going to name these angles. So let this angle be A, let this angle be B, let this angle be C, and let this angle be D. Okay, now note this point that this is a line, okay, and this is a ray which stands on this line. Okay, so for a moment, okay, so for a moment, if we try to, ignore this, can I turn it? Oh no, I don't think I can turn it. Okay, okay, so for a moment, let's try to ignore this part of the line and just focus on this part. Okay, so we can see that this is a line and this is a ray which stands on the line. So from axiom 6.1, this was our axiom. If there's a ray and if there's a line, then the sum of adjacent angle is 180 degree. Okay, so using axiom 6.1, now I'm going to write it down. Yes, I can write from axiom 6.1, we can say, what can we say? That A plus B is equal to 180 degree. Okay, we can say that A plus B is equal to 180 degree. Now, what I'm going to do is take this here. Yes. Now, once again, let's focus only on this line and this ray that we have. So once again, B plus C will be equal to 180 degree by the same logic because this is a line and this is a ray that stands on the line. So the sum of adjacent angles is going to be 180 degree. So once again I can say, so we can say A plus B is 180 degree and B plus C is equal to 180 degree. Okay, so let me quickly read what we have noted down. From axiom 6.1, we can say A plus B is 180 degree, B plus C is 180 degree. So hence, first we have both of them are 180 degrees. So we can say A plus B as equal to B plus C. Okay, A plus B is equal to B plus C. Now this, okay, now this B and this B, they are going to cancel each other out, and therefore we are going to have A as equal to C. And A and C are nothing but they are, now let's try to remove this, they are exactly the vertically opposite angles to each other. So this is our A and this is our C. Okay, so from this simple use of axiom 6.1, we have shown that A is equal to C. So A is equal to C, that's what the theorem says, that the vertically opposite angles are equal to each other. Again, by the same logic, we can very easily prove that B is also equal to D. Okay, so vertically opposite angles which are formed by intersection of two lines, they are always equal to each other. This theorem is very important and there are a lot of problems based on these theorems, and it's very handy to solve many exercises which we are going to see in the future videos. So quickly to revise, in this video we saw that first of all we saw that there are only two types of lines that exist in this world. One is intersecting lines and one are parallel lines, which are basically non-intersecting. Then we saw two axioms which are related to the adjacent angles and their summation being equal to 180 degree. And lastly, we saw a theorem which says that the two vertically opposite angles are equal to each other.